This is a problem based on the work power energy. Let us see. Very large forces are produced in joints when a person jumps from some height to the ground. Calculate the magnitude of the force produced if an 80 kilogram person jumps from a 0.6 meter high ledge and lands stiffly, compressing joint material 1.5 centimeters as a result. Be certain to include the weight of the person. In practice, the knees bend almost involuntarily to help extend the distance over which you stop. Calculate the magnitude of the force produced if the stopping distance is 0.3 meters. Compare both forces with the weight of the person. Okay. Now let us do the problem. Let me enter the data. So what is the data? Mass of the person is given as 80 kilograms. And then height from which he is jumping is 0.6 meters. And then the compression in the joints is the 1.5 centimeters. So that compression I will write as D. D is equal to 1.5 centimeters. That is equal to 1.5 into 10 to the power of minus 2 meters. That gives 0.015 meters. Okay. Now we have to calculate the force. We know from the work energy theorem, work done is equal to change in energy. Here, what is happening? The person is jumping. For example, let this be the situation. The person is standing here. Okay. And then he jumps from here to this point. Okay. So the distance is 0.6 meters. Okay, this distance. Initially, the person has the some gravitational potential energy, and then by the time he reaches the ground, UG becomes 0. Okay, so what is happening here? The person is doing the work. Okay, because of that, energy gets dissipated and then it becomes 0. Now we have to find out how much of the force is involved in doing this work. Here the work is done by the non-conservative forces. So F non-conservative times D is equal to change in gravitational potential energy, because the kinetic energy is 0 initially and then finally will also 0. We need not consider the kinetic energy. And then the downward direction is negative. And then here again, the compression is also, we will take compression as the negative. So the negatives and cancels off, though therefore you are left with work and the change in potential and gravitational potential energy. Therefore, F is equal to delta UG divided by D. Now you know UG is equal to mgh. Okay, here what is the value? M is the 80 kilograms, and then G is I am taking 9.8, and then H I will take 0.6 plus 0.015. That means I write here 0.6 plus 0.015. Entire thing divided by 0.015. This gives, no, I will not write like this. Only UG I will write. And then I will write the next bit. F bit I will write here. So F is equal to this one divided by G. So 80 times, not G, D times 9.8 times 0.615 divided by 0.015. This gives F value as 32,144 newtons. That is equal to 3.21 into 10 to the power of 4 newtons. Okay. Now he is asking us to find out if the stopping distance is 0.3 meters. Now we have to replace 0.015 with 0.3. Okay. So therefore B bit, this is the B, this is the A bit. Okay. And this is B. Now B bit, F is equal to 80 times 9.8 times 0.6 plus 0.3 divided by 0.3. This gives a value of 2352 newtons, or F is equal to 2.35 into 10 to the power of 3 newtons. Okay, now he's asking us to, third bit is compare the forces with the weight of the person. This is simple. Comparing means you have to divide. The first one is 32144 divided by 80 into 9.8, approximately 800. So that gives 41. That means this force is 41 times his weight. And then the second one is 2352 divided by 80 into 9.8. That is approximately 3 times. Okay, that is the question he is asking us to find out. Hope this helps. Okay. Thank you. Bye-bye.